So let me start to. This is a new topic. Uh, we want to talk about mechanical design of overhead lines and main component and isolator. So this lecture's titled Mechanical Design of Overhead Lines, which is a part of the Power Transmission and Distribution course, and focus on the essential structural and electrical aspects of overhead power systems. It begins with an introduction to the role of overhead lines in delivering electrical energy over long distances, highlighting their importance in modern power networks. The lecture then explored the main components of overhead lines, including conductors, towers, cross arms, and insulators, explaining how each contributor contributes to the reliability and safety of the system. A key, a key focus is placed on isolators, particularly the concept of potential distribution across suspension insulator string, which directly affects performance and insulation strength. So the lecture also introduces the concept of string efficiency and discusses why unequal voltage distributions can reduce overall effectiveness. Finally, various practical methods for improving string efficiency are presented, such as grading rings and capacitance control techniques and so on. Overall, this lecture aims to provide you with a clear understanding of both the mechanical design consideration and the electrical behavior of overhead transmission line components. Okay, in this slide, I just outlined the structure of today's lecture. We will begin with a brief introduction to the topic, setting the context and highlighting its importance in power systems. Next, we will explore the main components of overhead transmission line, focusing on their roles and characteristics. The presentation will then move on to analyze the potential distribution over suspension insulator strings, which is critical for understanding voltage behavior. After that, we will discuss string efficiency, explaining how effectively the insulator string performs under operating conditions. And finally, we will review various methods used to improve string efficiency, emphasizing practical techniques and engineering solutions. So, inshallah, we will discuss all of those things with each other. So, this slide explains the next step in the process after request has been successfully created, and um, it can you can see some a good video here regarding the overhead lines. So later on you can have a look. And overall, this slide highlights the to mention that what is the why how many type of the electrical cable do we have, and for example we can get some information about the underground cables and overhead lines, and what is the advantages and disadvantages of over both of these two types of electrical cables. And in this slide, I want to explain why underground cables are not commonly used for power transmission. The primary reason is their significantly higher cost compared to overhead transmission. systems, which limits their application mainly to distribution in densely uh, high populated or congested area with people, where safety and visual appearance are very important factors. Additionally, efficient power transmission requires high voltages to minimize losses and voltage drops. However, providing adequate insulation for underground cables to withstand such high voltages is technically challenges and expensive. Therefore, despite their advantages in specific environments, underground cables are generally less practical for larger scale power transmission. Okay, this slide also highlight the advantages of overhead transmission lines in power system. In these systems, bare conductors are used, and the air naturally serves as the insulating medium between them. And the required level of insulation is achieved simply by maintaining adequate spacing between the conductors, which makes the design both practical and cost effective. As a result, overhead lines provide a reliable and economical solution for transmitting electrical power over long distances, and they are widely adopted as the standard method for larger scale power transmission. Okay, this slide discuss the challenges faced by overhead transmission lines due to environmental conditions. Unlike underground systems, overhead lines are directly exposed to uncertain weather factors such as wind, ice, temperature variations, and other external disturbances can be available. So because of these uncertainties, it is essential to incorporate appropriate mechanical factors of safety in the design to ensure reliable and continuous operations. And in practice, transmission lines must be designed with sufficient strength to withstand the most severe expected weather conditions, thereby maintaining system stability and preventing structural failures. Okay, this slide, I want to introduce the main components of overhead transmission lines and emphasizes the importance of mechanical design in their performance. Overhead lines are widely used for both transmission and distribution of electrical power, and their successful operation largely depends on how well they are mechanically constructed. Since these lines are exposed to environmental conditions, it is essential to ensure that their mechanical strength is sufficient to withstand the most probable weather stress. So proper design and selection of components help maintain reliability, safety, and continuity of service in the power systems. Okay. In this slide, I want to outline the main components of an overhead transmission line and their respective functions. Conductors are the primary elements responsible for carrying electrical power from the sending end to the receiving end. Similar to transformers, we have sending end transformers and receiving end transformers. So here we have also the similar concept. These conductors are supported by structures such as pools and or towers, which maintain them at a safe height above the ground. Insulators are attached to the supports to electrically isolate the conductors and prevent current leakage to the ground. So cross arms are used to hold and properly position the insulators on the supports. In addition, several auxiliary components, including lighting arresters, anti-climbing devices, face plates, and danger plates, are incorporated to enhance safety, identification, and protection of the